Okay, so I want to continue with section 2.1. And when we started this section in class, I gave you the following problem. Find the secant line. So remember, secant line is a line which touches a curve at two given points. So find the secant line to the curve y equals x squared. Let me say y equals f of x equals x squared at x equals 1, and I think x equals 2. And we had this curve. You know what y equals x squared looks like. It's a parabola. Where's the teensy bit? And so we want the curve that crosses, we want the line which crosses the curve at x equals 1 and x equals 2. I'll do my best to sketch that line. We've basically already done this. And it crosses the curve at x equals 1. And to get the y coordinate for this curve, you just plug x equals 1 and you see what the y coordinate is. So 1 squared is 1. That's 1 squared. Why 1 squared? Because we're using the curve y equals x squared. And this point is x equals 2. That's the other x value we're given. And the y value is 2 squared, or 4. So that's just 2 squared. So x1, y1, x2, y2. The slope, oh, right. I forgot the word slope of. The slope of the secant line. So we did this again in class. So the slope is y2 minus y1 equal over x2 minus x1. Remember, the y's always go on the top. So in this case, we have y2 minus y1, 4 minus 1, all over x2 minus x1, 2 minus 1. So that's 3 over 1, which is 3. The slope of this line is 3. Easy. Didn't need calculus to be able to do that. Didn't need anything with limits to be able to do that. Let's take a look at a harder problem. So a tangent line as opposed to a secant line, which is a line which touches a curve at two different points. A tangent line is a line that just grazes a curve I'll put that in quotes since I'm just, again, counting on your understanding of the English meaning of that word. Just grazes a line, that just grazes a curve. At a given point, at one given point. So what if I give you a related problem? Find the slope of the tangent line to y equals x equals x squared at x equals 1. So again, let's go ahead and draw ourselves a picture. All on the board here. Okay, so y equals x squared, that's a parabola. So there's 2, there's 1. So that must be height 1 right there. This is 2. This must be at height 4. It's 4. So 1, 2, 3, 4. We want the line which just grazes the curve at x equals 1, as if we took a ruler and put it up against the curve at x equals 1. We want the slope of that line. So let me draw that in what I hope is visible as a different color, and I think is pink. The line which just grazes the curve there, as if we were to put a ruler up against the curve at that point. I wish I could ask you if it was clear what line I was after, but hopefully it is clear to you. The line which we just put this line up against the curve at that point, and it just grazes the curve. And we would like to know the slope of this line. And of course, we know it goes through the point x equals 1. And since we're using the curve y equals x squared, the y coordinate is just the square of the x coordinate. It goes through 1. That's just 1 squared. Now, hopefully it's clear why this problem is much harder than this problem. Over here, you're computing the slope of a line. Over there, you're computing the slope of the line. But over here, you have 2 points. Over here, you only have 1 point. How do you compute the slope of a line given 1 point? That's what makes this a much harder problem than this was. And hopefully that's clear to you. If it's not, pause and think about it for a moment. What we're going to do to get the slope of that line is use the idea of limit. So we're going to start at x equals 1. And we are going to move over a distance, which I will not specify. I'm just going to give it a letter. I'll call that distance h. So if we start at 1 and go over h units, that makes this point 1 plus h. We start at x equals 1, move over by h units on the x-axis. That makes this x value 1 plus h. And we are going to go up to the curve. The x-coordinate of that point is 1 plus h. The y-coordinate, we get the y-coordinate with this curve, with the curve that I gave you, y equals x squared. I didn't write that on here, but I could. Y equals x squared. This is the graph of y equals x squared. To get the y-coordinate for this curve, you just plug in the x-coordinate and see what you get. So I'm going to plug in 1 plus h wherever I see an x. So 1 plus h all squared. That gives me a second point on the curve. I'm going to connect this point, the point that I was given in the problem, with this new point that I sort of conjured out of nowhere. And that gives me a secant line. That gives me a secant line, a line connecting 2 points on the curve. Well, I can easily go ahead and compute the slope of that secant line. So I'll call the slope of the secant line m subscript sec, so I can keep track of it. The slope is going to be y2 minus y1 over x2 minus x1, the same as slope always is. So y2 is 1 plus h all squared minus y1 is 1 all over x2, 1 plus h minus x1, which is just 1. y2 minus y1 over x2 minus x1, that's always the way you compute slope when you're given 2 points. And we could do a little bit of simplification. Let me start by just doing a little bit of simplification on the bottom since it's so obvious. 1 plus h minus 1, this one and this one cancel out. So on the top I have 1 plus h all squared minus 1 all over just h. The two ones cancel out, the 1 and the minus 1. Okay, so I have the slope of this white line right here, which is great. I answered a question, unfortunately not the question I wanted. I want the slope of this line, this pink line, I think it's a pink line, but whatever it is, that just grazes the curve. Here's where the magic comes in. Here's where limit comes in. It's not really magic, but here's where limit comes in. So we've computed the slope of this line through these 2 points. What if h starts getting smaller? What if that point moves right there? I still use this point and now this new point. Well, now I can draw another white line between those 2 points. And that white line is closer to the pink line than this first one was. And if it gets closer, so I'm sort of balancing this ruler on the point that stays fixed here and this point over here. And as this point starts sliding down the curve and getting closer and closer to this line starts getting closer and closer and closer to the pink line. So the slope of the tangent line, the pink line right here, is this same slope that I just computed. So let me write it over here. So I'm just going to recopy this. I'm going to leave a space. 1 plus h squared minus 1 all over h. But I'm going to let h get smaller and smaller and smaller. I'm going to let the second point slide into the first one. And so I'm going to let h go to 0. As this point moves down the curve, this white line, the ruler, gets closer and closer and closer to the pink line in slope. The slope of that second line gets closer and closer and closer to the line that I actually want, the line which just grazes the curve there. Hopefully that's clear. Now, unfortunately, I can't just go ahead and evaluate this limit directly. If I try to put in h equals 0 directly, I end up with 1 plus 0. That's 1 squared. 1 squared is 1 minus 1. I end up with 0 on the top and 0 on the bottom. Well, we know that when we get 0 over 0, we have to do some algebra. We have to do some sort of factoring and canceling. Let's multiply the top out. So I'm going to keep writing limit as h goes to 0 because there's still an h over here. We're not using x anymore as my variable. Now I'm using h. We'll put that h in the bottom. 1 plus h squared. We reviewed this during our pre-calculus review. That's not 1 squared plus h squared. We know that exponentiation does not distribute over addition or subtraction. That's really 1 plus h times 1 plus h. And we have to FOIL that all out. So let's do that. So we're doing some algebra here. 1 times 1 is 1. 1 times h is h, plus another h, that's 2h. H times h is h squared, minus 1. That minus 1 is that minus 1 right there. So we just FOIL this out. Let's see how much more Blackboard space I have. So I'll continue that right over here. There is an obvious simplification to do on the top. I have a plus 1 here and a minus 1 over here. They cancel out. So I'm just left with 2h plus h squared all over h. 2h plus h squared all over h. And now I could factor an h out of the top. So that leaves me with a 2 in the first term and an h, and oops, got my plus sign, and an h in the second term, all over h. And I'm looking at that, I feel very good all of a sudden because I have an h on the top and that h on the bottom, which was causing all the trouble when I tried to plug in h equals 0. But now I can cancel this h on the top with this h on the bottom. So when I cancel the h on the top and the h on the bottom, I just have the limit. This h goes to 0 of 2 plus h. And now there's no problem plugging in h equals 0. I end up with 2. And I just found out that the slope of this pink line is 2. Even though I only had 1 point on the line. I only had 1 point on the line. I sort of conjured a second point out of nowhere. I moved over by distance h. So if I started at x equals 1, I move over by distance h, I'm at 1 plus h. And the y coordinate, I just plugged it into the curve, y equals x squared. So if the x coordinate is 1 plus h, the y coordinate is going to be 1 plus h all squared. I did y2 minus y1 to get the slope of that secant line. And then I let h get smaller and smaller and smaller and go to 0, letting that second point slide into the first one to get the slope of the secant line. So our tangent line has slope 2. If I want the equation of the tangent line, now it's easy because I have a point on the line, I have a slope, I can go, y minus y1 equals m times x minus x1 if I want the equation of the line. Now that I worked out the slope's the hard part. I can do it. So we were able to compute the slope of this line, even though we were only given one x value, which was the challenge. We were able to find the slope of the line, which just grazes the curve there. And again, I hope it's clear what I mean by just grazes the curve. I think in the interest of keeping this video from getting too long, it's much harder to watch a long video than it is to be in a longer class. I'm going to stop the video now, and I will see you all on Thursday, back in our usual location.